In this video, we are going to learn to condense and expand logarithmic expressions. But first, we need to hop on over to the black screen for a brief tutorial. There are a couple properties of logarithms that you have to understand. If you take the log, and it really could be any base, so I'm just going to say base b. Say if I do the log base b of two things that are being multiplied together, like a times b. Oh man, that's bothering me. I'm going to make this a c because I don't want the same letters. Log base c of a times b. This will expand as log base c of a plus the log base c of b. So the log of multiplication can expand as two separate logarithms connected by addition. Now similarly, if this was the log of a divided by b, then this would expand as two separate log equations, but now it expands as subtraction. All right, so the log of a quotient is equal to the difference between the two logs. And it is a two-way street. Okay, so if I start with something that's written in expanded form, like for example, log base 2 of 5 plus log base 2 of 7. All right, I could condense these into a single log, turning it back into multiplication, 5 times 7. All right, which of course would be log base 2 of 35. So it is a two-way street. All right, the sum of two logs can condense down to a single log of multiplication, and the log of a multiplication, a product, can split apart as a sum. Okay, and similarly, if this had been subtraction, then I could have condensed this as 5 over 7, and that would be the end of it. Let's see, let's say this had been 35 though, then it would have been 35 over 7, and then that would have reduced to log base 2 of 5. So that's half the battle, understanding those two statements. But there's something else you need to know. Exponents. If I have log base 2 of x to the third power, this is considered condensed. Now I've got this exponent here. Now in expanded form, this 3 can go in the front. So this would be equivalent to having the 3 in the front. And then you still got the rest of it, log base 2 of x. All right, and this is a two-way street. Let's do another one. So say if I had 5 log base 2 of m. In condensed form, this 5 is going to end up as the exponent. So I'm going to have log base 2 of m, but this 5 is going to wind up as the exponent. Okay, so it would be to the 5th power. Okay, what else? All right, so there's like one more thing I need to tell you. And remember this. Square root is the same thing as the 1/2 power. So if I gave you the log base 3 of the square root of x, all right, this would be the same thing as the log base 3 of x to the 1/2 power. And in expanded form, this 1/2 is going to go in the front. So it would be 1/2 log base 3 of x. Okay, similarly, what if I had 1/3 log base 5 of p? All right, this is in expanded form, but in condensed form, this 1/3 has to wind up as the exponent. So this would be log base 5 of p to the 1/3 power, but we wouldn't leave it that way. We would go ahead and write log base 5 of the cube root of p. So that's something that's going to happen, so watch out for that. And I just remembered one more thing I got to tell you. Let me erase all this mess first real quick. Now, here's one more thing I have to tell you. So far, I gave you these expressions separately. I gave you things like this: log base 2 of 8 plus log base 2 of 4. And you now know that that would equal the log base 2 of 8 times 4, which would be log base 2 of 32. And then I gave you subtraction problems. So log base 2 of x minus log base 2 of 7 would be log base 2 of x over 7. Okay, but what if I give you addition and subtraction all in one statement? What then? You know what, let me say it the other way first. What if I gave you log base 2 of a b over c d? So here I have multiplication happening, but I also have division. All right, this whole thing is a fraction. I have a, b, c, and d. All right, this is going to split up into 4 different terms, and anything in the numerator is going to give us a positive result, a positive expression. Anything in the denominator will be negative. So from the numerator with a and b, I'm going to have log base 2 of a. That's positive. And then I'll have to say plus log base 2 of b. All right, now in the denominator, I have the c and the d. So those are going to be negative log. So I will say negative log base 2 of c and negative log base 2 of d. So this expands out to equal all of this. Okay, just remember, anything in the numerator is going to give you a positive. Okay, this is understood to be positive. Anything in the denominator is going to give you a negative term. Okay, and it works the other way too. So if I give you log base 2 of 5 minus log base 2 of 3 plus log base 2 of x minus log, a little bit more space, base 2 of y. Say if I gave you all those things. So this can all condense down to a single log. All right, I see the minus, so I know I'm going to have a fraction. Anything that is positive is going to end up in the numerator. So this first term is positive, so that 5 is going to be in the numerator. This second term is negative, so this 3 will be in the denominator. This term is positive, so this x will be in the numerator. This term is negative, so this y will end up in the denominator. Okay? So you needed to know all of those things I just explained to you to be able to do this problem. All right, so the first thing we have to do is use what we call the exponent property. That's the one that says if you have a number in front, a coefficient, when you're dealing with logarithms, you can put it on the inside as an exponent. So you can move it from the front to be an exponent. So I have 2 coefficients here. I'm going to take each one of them and I'm going to move them and put them as exponents. Okay, so if I rewrite the problem using the exponent property, I've got log base z to the 4th power minus log, did I say log base z? Log base 6 of z to the 4th power, log base 6 of x to the 1/3 power. Now, let us not forget z to the 4th power. 1/3 power is the same thing as the cube root. So let's go ahead and do that. Now, this subtraction lets me know that I'm going to be using the quotient property. If you have subtraction happening between two logarithms, that condenses down to a fraction, division. Okay, so this is going to be log base 6 of, the positive one is going to go in the numerator, so z to the 4th power. The negative one is going to contribute to the denominator, so cube root of x here. And this is fully condensed. That would be the answer to number 11. Alright, we're going to need some more practice on that. Oh goody, this one has 4 terms to it. Don't worry, anything positive will be in the numerator, anything negative will show up in the denominator. But once again, first of all, let's use the exponent property. Anything in the front is going to become an exponent. Okay, this has no coefficient, but this 2 is going to jump over and become an exponent. This 4 is going to become an exponent. So let's go ahead and do that first. So we'll have natural log 4 plus natural log x squared minus natural log y to the 4th power minus natural log 9. Alright, always do that first. Now, all 4 of these terms are going to smash down into a single log expression. Natural log of. So the 2 things I have in the numerator will be the 4 and the x squared, because those are the 2 terms that were positive. These 2 terms, see how they are negative? They will contribute to the denominator. So I've got y to the 4th power and 9. Alright, of course I'll write 9y to the 4th power like we usually do. And I'm looking to see if anything will reduce, but nothing reduces. So this is going to be the final answer. Okay, now expanding is moving in the opposite direction. This time we're starting with 1 log and we'll end up with multiple logs. Okay, so be careful because it looks like we only have 2 things, x squared and 5y. But really we have 3 things. So it might be helpful if you understand this. So I have natural log x squared. Now this square root, I could split this apart into the square root of 5 and the square root of y. Alright, that's like 2 separate things. Now, in preparation to do my exponent property, this time I'm expanding. So I'm going to take exponents and I'm going to put them in the front this time. So I'm going to turn these square roots into exponents. So this would be the same thing as natural log x squared, 5 to the 1/2 power, and y to the 1/2 power. Alright, because we know the square root is the same thing as the 1/2 power. Okay, it's not time to do the quotient property yet though. First we're going to do the product property. Alright, when you have things multiplied together, you can split them apart as addition. Alright, this is all multiplication. Alright, there's no denominator here. So that means this will split apart as all addition. So I'm going to make this into 3 terms. So natural log x squared plus natural log 5 to the 1/2 power plus natural log y to the 1/2 power. Now all I have to do is put each one of these exponents in the front according to the exponent rule, the way I can just move that c to the front like this. So this when this 2 moves to the front, it will become 2 natural log x. When this 1/2 moves to the front, it will become plus 1/2 natural log 5. And when this 1/2 moves to the front, it will become plus 1/2 natural log y. And that, my friends, is as far as we can go. Okay, by the way, this is L for log. I know it's kind of backwards, but this is natural log. So don't ever write this. When you're trying to write natural log, I will see some kids write IN. It's an L. So if you want to do it in sort of a different way, make it a cursive L. Whoops. If you like, this sort of looks like 21. So I understand the temptation to go like this so it doesn't look like 21. But rather than do that, you should make a cursive L. Okay, because it's an L, it's not an I. Alright, just thought I'd throw that in at no extra charge. Alright, I think we have one more of these. Okay, now this time I see that fraction. I have denominator. That means there's going to be some subtraction going on. So look, I have 3 things here. I have x, and I have 3, and I have y to the 3rd power. Alright, one of those is in the numerator, 2 of them are in the denominator. So the one that's in the numerator is going to give me a positive term. So I will have log x, keep it positive. These 2 are going to be negative because they're from the denominator. So minus log 3 minus log y to the 3rd power. Okay, so I have simultaneously done my product property and my quotient property. I just do all that at once. Okay, I've got addition and subtraction. I took care of it all. But what I haven't done yet is my exponent property. If I have any powers, time to put them in front. I only have one exponent. This 3 needs to jump right to the front of its term. So I'm just going to bring this down. Log x minus log 3 minus. Now this will be 3 log y. And that is expanded form. That's the final answer. Alright guys, that's the end of this video. I hope it was helpful. I will see you on the next video. Alright, in the next video we will use these properties to evaluate expressions like these without touching a scientific calculator.